Okay, so it looks like we're going to try to find the domain of a function, not using our graphing calculator to do the finding. We might verify it, we might look at it, make sure things check out after we do our calculation. But the idea is that we shouldn't depend on the calculator. We should be able to use our own brains to figure out what is the domain of this function. Well, the domain of a function it's the set of x values that actually get mapped to y values, right? They get mapped to outputs. And so it's the set of allowable x values. It's the x values that are allowed to be used by our function. Now, in this class, we haven't talked about what a complex number is yet. And so we're going to restrict the domain of this function to be a real number. It's not that the numbers don't exist per se, it's just that they're a different type of number. And at this point in our mathematics career, we're going to save those for later. And so right now, when I'm talking about the domain of this function, what am I going to do? I need to restrict the domain because there are some x values that I'm not going to allow into my function. And they're the ones that make my square root, the value underneath my square root, negative. Because anything that's a negative underneath that square root becomes a non-real answer. And I'm saying I'm not going to include non-real answers in my domain. So what I have to do is I have to take everything that's underneath that square root. Notice that this is because this is a square root. A square root would be like writing a 2 there, but we use this one so often we don't write the 2 there. So this would be the same thing for a 4th root or an 8th root, any even root. A cube root or a 5th root or a 7th root, an odd root, like a cube root of number, a 5th root of a number, or a 7th root of a number. Those being odd roots, they are just fine as far as negative numbers go. They don't give us complex numbers or imaginary numbers, whatever you want to call them. So it's only for these even powered roots, or x to the 1 over an even number, that give us this problem. Okay, well, what I need to do is I need to take the stuff that's under that radical, my 7 minus x, and I need to say, well, for that radical to output a real number, the stuff that's under that radical must be 0 or greater. Because the square root of 0 makes sense. Square root of 0 is 0. Square root of 1 is 1. Square root of 2 is irrational, but it makes sense. So that's going to be my 7 minus x is what's underneath that radical. It must be greater than or equal to 0. Then literally I just solve the equation for x. And so I'm going to add x to both sides here. That's a terrible version of writing plus x. And the whole reason is because then negative x plus x gives me a 0 there. What I do to one side of the inequality, I have to do to the other side of the inequality. The only exception being if I multiply or divide by a -1, I have to change the direction of the inequality. But I'm not doing that in this case, so I don't have to change the direction of the inequality. I'm just adding to both sides of my inequality. Well, what's that say? I can flip the direction to make this something that's maybe a little bit more readable to us. Well, let's actually try to write it down right. We have x is less than or equal to 7. Well, I could say that my domain is negative infinity up to a positive 7. But it does include that 7, so I use a bracket. Or I could say that my domain, that would be my interval notation, I could also write this in set notation where I could say that x is a real number such that x is less than or equal to 7. That would be another good way to write it. Your textbook actually leaves off the is an element of the real number set, but this is math speak, but it's important. This kind of funny sideways pitchfork that looks a lot like an E could be read is an element of, and then this funny looking R with kind of the gap there is the set of all real numbers. And so the way you read that, and then this vertical bar reads such that. And so if I'm translating this thing, that thing literally translates into a sentence. X is an element of the real numbers such that X is less than or equal to 7. We just compress that into a set of symbols. All right, well, let's take a look at that as a graph. Kind of see if we understand, because domain's my inputs, right? They're the X values. Clear out what I was working on before. Second, X squared gives me my square root. And then I do 7 minus X. And if I think I know what my domain is, my domain is that X must be less than 7, then my window of negative 10 to 10 sounds pretty good, because 7 is nicely in there. So X min we could put as negative 10, X max we could put as 10, Y min we could put as negative 10, Y max we could put as 10. All right, hit that graph. And you can see, if I pan around here a little bit, as I get closer and closer to 7, I don't have outputs for X values larger than 7. But I do have outputs for an X value of 7, and I can see that really easily if I say calculate, and I find a value for X equals, and I put in the number, show keyboard, I put in the number 7 there, and have it calculate that number. Notice that it's actually calculating for X equals 7, Y equals 0. But if I try to have it calculate a number larger than 7, it's going to return an N, because I won't be able to do that calculation. Try that. See how now Y is an N because it's not part of the domain? But if I take that back to 7, it's a 0 because 7 is part of the domain. And so I do get a Y value for an output. All right, so that's just the calculator confirming what we already knew. All right, I hope that helps.